Hey, welcome to Physics Surf. So, how many of you guys watching this video have wondered what's happening outside of this planet? Well, think bigger. What's happening outside of this solar system? Bigger. What's happening outside of this galaxy? At what rate are the galaxies moving apart or close to each other? Let me tell you, there are more than 2 trillion galaxies in the observable universe. So there has to be a certain uniform movement along with the galaxies to define the entire moment of the universe after the Big Bang. Let's find out. So in this video, whenever I draw a dot, it means a galaxy, because the universe is not made of stars or planets or the other celestial bodies. It's actually made of galaxies. Now, what's happening inside a galaxy is a totally different story, because galaxies are crunching themselves slowly. But what's happening outside of the galaxies, like in the universe, there's a clusterfuck of galaxies everywhere. Now, the relative moment of these galaxies is what defines the aftermath of the energy soup formation expansion, or some people like to call it the Big Bang. So let's check out what happens. So 2 things you need to keep in mind before jumping in is that number 1, the galaxies in the universe are equidistant from each other. That's the homogeneity principle. Wherever you go in the universe, the galaxies are moving apart, but the distance between any 2 galaxies is going to be the same. That's the homogeneity principle. And the other thing is that whenever you watch a universe from one point, it's going to be similar if you watch a universe from some other point. The universe appears similar at any point. Yeah, that's isotropy. Universe looks same from every direction. So scientists captured the photons that were emitted from distant galaxies, and they measured their wavelengths. And the more redder the wavelength is, the more redder the photon is, the more distant the galaxy, the more farther the galaxy is traveling. That's the concept of redshift. So by doing this, scientists discovered the cosmic microwave background, which is a very interesting topic. I might make a video about this later, but anyways. So scientists discovered that the galaxies are moving apart, away from each other at an increasing speed. So let's prove this mathematically. So let's assume a linear setup of galaxies in 1 dimension. 1 dimension because anything in 3 dimension is the same. So I'm just assuming 1-dimensional galaxy setup for a better understanding. So according to the homogeneity principle, as you guys know, the distance between the 2 galaxies is a here. So now let's assume, not just assume, let's say, what's the distance between galaxy number 1 here and some nth galaxy? It's simple. A times n. So distance d should be equal to a times n. What if I differentiate both the sides with respect to time? So whenever I put dot over anything, it means I'm differentiating that part with time. N remains constant, so the change in distance between the 2 selected galaxies is equal to the change in distance between the 2 neighboring galaxies over time times n. Clear? Now, what if I add, what if I multiply and divide the right hand side with a? N times a over a. What you know from before? N times a is nothing but d. D equals n times a, which is the distance between the 2 galaxies that we just assumed, right? So I can just write n times a is d, and d dot is the change in the distance over the change in the time. What is change in distance over change in time? It's velocity, the recession velocity between the 2 galaxies. So velocity is equal to a dot over a times the distance. That's right, the distance. So a dot over a is a parameter which doesn't depend upon n, and this is what called as the Hubble's parameter. It is the change in distance between the 2 neighboring galaxies per distance between the 2 neighboring galaxies. Let's see what the Hubble's law says. So the relative velocity of the 2 galaxies is proportional to the distance between them. As we just saw, velocity equals a dot over a times distance. A dot over a is also called as h. So velocity is equal to h times d, or velocity is directly proportional to distance. Now, with various concepts of redshifts and the cosmic microwave backgrounds and everything, scientists discovered that the value for the Hubble's parameter is 71 kilometers per second per megaparsec, where 1 megaparsec is equal to almost 3 times 10 to the power 22 meters, or 3.2 million light years. So, what this means is that when the two galaxies are 3.2 million light years apart, the velocity between them, or the velocity with which the two galaxies are moving apart from each other, is 71 kilometers per second. And as we increase the distance between the two galaxies with the multiples of 3.2 million light years, the velocity increases with the same multiple of 71 kilometers per second. Apply the math here. So this is nothing but the Hubble's law.